out of your day to be here. My name is Aditya Chaurasia, and over the next 1 hour, I am going to show you something that I think will be fundamentally changing how you think about accessing data in our organization. And by the end of this session, you will see how anyone, regardless of technical background, can extract insights from complex data sets using nothing more than plain English. No SQL, no Python, just questions. Let me start with a scenario. I think every single person in this room, especially the folks from AmeriCold data team and other people, would definitely be aware about it. So, like, how many times have we heard this question? Pulling up the in pellets count or sales numbers by region or district for any quarter of the financial year. And, you know, it sounds simple. The data exists, but we know that it's in a database somewhere. But here's the reality. Like, even for a skilled data engineer or data scientist, answering that question essentially takes about 15 to 20 minutes. And that's not them being slow, but that's part of the professional, careful work that we happen to perform. Okay. And first, we need to understand like what exactly the data that the business stakeholder is asking about. Then we need to write the appropriate SQL or Python query. Then we need to test it. And after testing, because nobody wants to, send us the wrong numbers, then we need to validate the results and probably then format it so that it is actually is useful to business stakeholders. Okay. So like 15 to 20 minutes for just one question. Now multiply that across every ad hoc question asked in, every client meet during a week. And what if I told you that the same question could be answered in, like few seconds, not by replacing our data team, but giving everyone in our organization the ability to ask the questions directly. And that's exactly what Pandas AI does. So let me introduce you to Pandas AI. So Pandas AI is an open source library that brings the power of LLMs to data analytics. But let me explain what that actually means in plain terms. So you ask, your question in natural language, plain English, in the similar way you would ask a colleague. Pandas AI translates that into executable code, SQL or Python behind the scenes. It runs that code against your actual data and it returns the answers. This time in seconds, but no, and not in minutes. And the business user never sees the code. They just ask a question and get an answer for it. And now I know what some of you are thinking. So this sounds like magic, or was like marketing stunt. So I am not going to ask you to believe me. I am going to show you. We have built a proof of concept using realistic e-commerce data. And in a few minutes, you are going to watch me ask questions in plain English and get answers in seconds. But first, let me show you exactly how this works under the hood. So, all right, let me pull back the curtain of how this actually works. And so, like when user asks any question, it flows through this pipeline. First, Pandas AI analyzes your natural language query, and this isn't just going to be a keyword matching. It's actually parsing your question to understand the user intent. Are you asking for a sum? Are you asking for a comparison? Are you asking for a trend, a visualization? It figures this out from how you phrase the question. Okay. Next, it identifies which tables and columns are relevant. If you ask about customer segments, it knows to look it into the customers table. If you mention revenue, it maps that to the orders table and total amount column. And this happens, uh, this mapping part happens automatically based on the schema that is sent through the Pandas AI. So in so here's the critical part. Now this system sends a prompt to the LLM that could be GPT-4, Claude, or even a local model, running entirely on Olama on our local desktop. And this prompt includes your question and the schema. And schema implies table names, column names, data types, etc. But here's what is important: it does not include your data. The LLM server sees that a customer named Ravi Bhatia placed an order for $500. It only knows there's a customer name column and a total amount column. The LLM then generates the Python or SQL code based on our question and the schema context. The code then executes locally on your machine against your actual data. And finally, whether the result is a number, a table, or a chart, it comes back to you. And this whole process takes a few seconds. So, to summarize, your question and schema go to the cloud. Your actual data stays local. The AI writes the code, but the code runs here on your data. And now let me show you what happens in each of these steps in more detail. So let's go one level deeper. When you type a question, Pandas AI just doesn't pass your raw text to the LLM. There is a sophisticated pre-processing pipeline that happens first. So step one is tokenization. The system breaks your question into a meaningful phrases and concepts. So, if you ask like what is the total revenue by customer segment for say Q4 2024, it is going to identify total revenue. Uh, that's an aggregation operation, specifically a sum. Customer segment, that's a grouping dimension. Q4 2024, that's again a time filter. And this tokenization is more intelligent than simple word splitting. It understands that total revenue is a concept and not two separate words. And step two is intent detection. So the system classifies what type of operation you are asking for. Is this a simple aggregation, like give me a sum or count, or is it a filter, like show me a few records where something if else condition is provided, or is it a comparison or a visualization or some sort of a trend analysis? Now, getting that intent right is really very crucial. Like if you ask, show me the top customer, the system needs to understand that you want a ranking, probably by revenue, probably limited to some, reasonable top number like top 5, top 10, etc. So intent detection handles that ambiguity. And step three is entity mapping. This is where your business language gets connected to actual database columns. When you say revenue, the system maps that to total amount in the orders table. And when you say like customer segment, so it maps to the segment column in customers. Now, here's something important, like the system makes educated guesses based on the column names and common patterns. It knows revenue probably means a money column, but it doesn't know your internal terminology in your database or the column name. If your company calls high value customers the whales, the system won't automatically know that whale means segment equals, say, enterprise. So this is something we can configure and improve over time. And like step four is schema matching. So the system here determines which tables are needed and how they connect. If your query needs both order data and customer data, it figures out that orders and customers join on customer ID, uh, and like it infers these relations from column names, etc. You know, associated with similar data types. There's probably some sort of a join key, and the output of all this processing is a structured query plan. It's not code yet, but it's a structured representation of what you are exactly asking for. And this query plan is what guides the next step, that is the code generation. So when a query works perfectly, it's because all four of these steps succeed. And when a query gives you an unexpected result, it's usually because one of these steps misinterpreted something. And what's the good news? You can often fix it by rephrasing your question to be more specific. Now, let's look at how that query plan becomes the actual executable code. So, this is where the magic happens, the code generation part. So, we construct a carefully engineered prompt, uh, and this isn't like hey, write some Python sort of thing. There's a proper structure, proper prompt that dramatically improves the quality of generated code. First, there's a system message. This tells the LLM what role it is playing. Like you are an expert Python data analyst, or experienced data engineer. You write clean, efficient pandas code or SQL queries, something like that. Uh, Next, we include the schema context. This is where the LLM learns about your data. It sees table names, column names, data types, and relationships. And again, this is metadata only. The LLM sees the total amount is a float column. It never sees that, order, say 1, 2, 3, 4, 5 had total amount of $523.47. And next is we include some rules or constraints. So these are the guardrails that improve our code quality. Then we include the parsed query from the previous step, the intent, the entities, the filters, all structured clearly. And then the LLM takes all of this and generates the Python code, typically pandas code for in-memory data, or SQL for large scalable database connections. But here's something critical. We do not blindly execute that generated code. The code goes through a validation layer first. This validator checks for syntax errors, basic stuff, and it scans for unsafe operation, like is the code trying to write to the file system, then it is going to block. Then is it trying to make some network calls, then again it is going to be blocked. No, something like that. And only after validation filter, the code moves to the execution environment. And that environment is sandboxed. Even if something slipped through validation, it cannot cause any damage. So the entire round trip parsing, prompt construction, LLM inferencing, validation, execution typically takes like 3 to 15 seconds, depending on the complexity of the query that you asked. And compare now that to 15 to 20 minutes that a developer would need. And also you will be able to see the generated code. Pandas AI is fully transparent, and if you want to verify like what exactly what logic was applied to get to your answer, you can inspect it. Then uh, the, the main pain point is, can this handle our production databases with millions of rows? So let's talk about scale. because our data warehouses has hundreds of millions of rows, and pandas cannot handle that. And pandas in memory has limits, but pandas AI has multiple operating modes designed for exactly this challenge. So mode one is in memory processing. So this is what you saw in my architecture diagram. Data gets loaded into pandas data frames and processed there. This is the fastest mode for data sets that fit in memory, typically up to a few million rows, depending on your column count and available RAM. And our POC with 50,000 rows comfortably in this zone can be tackled. Response times shall be in single digit seconds. Mode 2 is SQL mode, and this is the key for large scale production data. So instead of generating pandas code, pandas AI generates SQL queries that execute directly on your database. And the LLM still never sees your data. It generates SQL from schema metadata, but the execution again happens in your database engine, which is optimized for exactly this kind of work. So just think about what this means. You have a snowflake warehouse with a billion rows. Pandas AI generates a SQL query. Snowflake executes it using all its distributed computing, and the result comes back. The LLM wrote the query, but your data never left your warehouse. Okay, next mode is the chunk processing. This is for medium to large files when you don't have a database connection, but also you cannot load everything into memory. So Pandas AI processes the data in batches, first in million rows, and then next million aggregating results as it goes on. So this is useful for very large CSV files or Parquet files that exceed your RAM but still don't live in a database. And finally, we have native connectors for major data platforms like Snowflake, BigQuery, Databricks, Redshift. So these aren't just SQL connections; they are optimized integrations. That leverage each platform's specific features. So the beauty is that Pandas AI can auto detect your data size and recommend the optimal mode. For a small CSV, it uses in memory. For a warehouse connection, it generates SQL, and the user experience stays the same. You ask a question, you get an answer, but the backend adapts to your scale. So yeah, this can handle production data, and the architecture is designed for it. But for our POC use case, we have used the in-memory mode. Say like 50,000 rows is comfortable, but the same tech can scale to enterprise data as well. Next is about the crucial thing, that is security, which is non-negotiable. And layer one is the data residency. So your raw data shall never leave your environment. Not one record, not one value. The LLM does not see that customer Ravi Bhatia or Manu Chandra, you know, bought product XYZ for $1,000. It sees that a customer name column exists of the type string and the total amount column of type float, metadata and not data. So the code generated by LLM executes locally where your data lives, and the results stay with you. And the next layer is API communication. When you use cloud LLM providers like OpenAI or Anthropic, uh, what actually gets transmitted is your natural language question. The schema structure, the table names, column names, data types, that's it. This is all that goes into LLMs. And the response coming back is your code, and the code then runs locally. So even the computed results don't go to the cloud, and this cloud just helps writing the query. Then next layer is personally identifiable identity detection data and masking. So we have built in automatic detection of personally identifiable information. So the system scans your schema and identifies columns that might contain sensitive data such as email addresses, phone numbers, Aadhaar card numbers, credit card numbers, etc. And these can be automatically masked, either hashed or anonymized before any processing. So the masking is consistent, and we have like four different types of masking levels. Then layer 4 is the local LLM option, that is using Olama or LM Studio if you have heard of. So for maximum security, you can run everything locally using Olama. Uh, and like there are like zero network calls to any external API, and your question never leaves your network itself. The schema also never leaves your network. Everything stays inside your firewall. And the trade-off for this local LLM option is accuracy. Local models are for sure going to be smaller than GPT-4 or Claude, Sonnet, etc. models. So you get around like 60 to 70% accuracy instead of 90 to 99% accuracy. But for regulated industries like healthcare, finance, etc., this trade-off really makes sense. Uh, then the next and the final layer is audit trail. So every query shall get logged. Every piece of generated code is captured. Uh, and like who asked what, when, and what code was executed to answer it. So this all gets recorded. So next is the LLM provider options. So one of the Pandas AI greatest strength is the flexibility. Uh, in which the which AI model we are going to select to power our system. So you are not exclusively logged into one vendor, and you can specifically use OpenAI, Claude API, Azure, Together AI, Olama, etc., etc. Okay. Next is performance benchmarks. So I will probably run through a few codes, then probably talk about it. Let me check if just a second.
Aditya, are you showing us some other screen right now? Because we can only see your slides, nothing else.
Just a second. I'm just opening my code base for the demonstration purpose. Just a second. It's tagging.
Okay.
Aditya, you should have opened it before the presentation itself.
Yeah, just a second.
Aditya, is this going to take time?
So this is the data set. So the data set comprises of you know several files: customers, products, orders, order items, payments, reviews, and inventory. And I have specifically used Together API as the LLM provider because this Together AI speciality is that you can tweak and play around with a couple of hundred LLMs that are in vogue as of now. So yeah. So first, let me demonstrate you the traditional approach. Finding. So the business question is find top five customers by revenue who made purchase in 2024, showing their segment and total spend. So this is the traditional pandas approach. 12 lines of code. So this is uh, lines of code are 12. Execution time is minimal. And this is like the pandas AI approach, the natural language query. So we have already initialized the agent a few cells above. And here's what we generally ask uh, pandas AI. And yeah, in just one line of code, response time is 0.27 seconds. it is able to get back to the same output that you are seeing over here. Digital Solution Incorporated Enterprise, $910,000. Cloud Hub Works, Global Labs Inc., Digital Corp, so on and so forth. Solution remains the same, just that we have used Pandas AI here. So here the side by side comparison. So Pandas AI just takes one plain English sentence, and just 10 seconds are required for Pandas AI, and instead of traditional Pandas we are utilizing like 5 to 10 minutes of developers bandwidth, and here almost anyone can ask the question and get the answer to the query that is asked. So under the hood, now let me show you the architectural overview by running in this sample code. So yeah, so first part is query parsing. Then after that prompt generation happens, then code generation, and then it checks the caching, whether the question that was asked by the user has been asked before or not. By that way it can accelerate your power to query even more by caching. And this is the sort of code that gets generated by Pandas AI, and then we are able to see the outputs here, which has been plotted here. Next is like query parsing and schema understanding. So it tokenizes our query into meaningful context, and detects the aggregation type, the sort of things that we are expecting in order to map the entities, identifying the relationship between various columns in multiple tables and joins, etc. Okay. Then next is the code generation engine. So I have created here this so every query is going to generate some pandas or Python code, and this is what the LLM is going to produce. So now that we have looked into the internal architecture and internal working of Pandas AI, now let me demonstrate some of the key features of Pandas AI with different types of queries that a business user or QA engineer or BI developer or business analyst or data engineer can ask and get the outputs. So first is the simple aggregation. What is the total revenue from all orders? So this is the output. Response time is 0.24 seconds. Next is multi-table join. What is the total revenue by customer segment? So it generates the relevant visualization. Next is somewhat complex filtering, like show me orders over $10,000 from enterprise customers in 2024. Let me run it. Result. So this is the output for the same. Orders are well above $10,000, as can be seen here in the subtotal column, and the order dates are also visible. Okay. Next is the time series analysis, like show the monthly revenue trend for 2024. Sunning generated. So the response time is 5.04 seconds. This is the monthly revenue trend graph. Next is the bar chart visualization. Create a bar chart of revenue by product category. So this is again done in merely 2.89 seconds. Then pie chart, show the customer distribution by region. So it's generating. So again 3.39 seconds. This is the customer distribution by region. And correlation analysis. Is there a correlation between product rating and sales volume? We do that. You see. So here we come across a limitation of Pandas AI. Probably, it is unable to identify some column name or something like that. So yeah, ultimately, nobody can replace developer or human. At the end, we require a specialist to debug as to what schema, what context, what query got generated into what sort of code that gave us this error. So as I told you before, in the uh, query parsing pipeline itself, if there is some sort of you know glitch in intent detection, entity mapping, etc., then you will come across such sort of failures in executing whatever query that you intend to ask. Next is comparative analysis. Compare average order value between different customer segments. Let me run this. So this is it, 3.47 seconds. Consumer versus enterprise, professional, and small medium businesses. This is it. Then some predictive complex query. Which products have high sales but low inventory, less than 100 units on hand? See, we have also specified what refers to low inventory here, but we did not specify the high sales. Let us see what Pandas AI infers from this. You see, it returned null, empty data frame. Probably again, there might be some error in some part of query parsing pipeline, that is intent detection or entity mapping, that led to again this sort of thing. The next
So
thing is
Aditya,
role specific
just
queries. So like
uh,
if you are a finance guy or from execution side, you can ask like various type of questions. For instance, here, what is the month over month revenue growth for 2024? So it has generated a
Aditya, we have got a
month
question
over
out here.
month revenue is plotted in revenue growth.png.
Aditya?
This is the output. Then this is the marketing. Similarly, this can be seen. And for operations, which day of the week has the most orders? What is the busiest day of the week? So
Aditya, can you hear us?
it is able to answer. Let's see. So orders are, much more symmetrical only because I had generated synthetic data for this POC point of view. That's why it shows in nearly equal orders by day. Now your turn. Would anybody like to ask any interactive query with respect to any data? Like
Aditya, are we audible to you?
we have this data, raw data set here. You can ask anything.
I guess we are not audible to him.
Hmm.
Literally
Aditya, are you
anything.
audible to you? Aditya, can you hear us?
Or any queries that you have.
Aditya? Aditya?
Yeah,
Okay, now we are audible to you.
yeah.
Okay, because previously, yes, we were not audible to you. Anyway, so we can ask questions because in between also, someone tried to ask you questions. So please, I guess Ayushman raised his hand.
Yes, am I audible now?
Yeah,
You are
Ishman, go ahead.
audible
Hello.
to me.
Okay, okay,
Aditya, is he audible to you?
Yeah, yeah, yeah.
okay. So
Yes,
Aditya,
please.
from this, what I can see is some query that requires a natural language response is a limitation to this thing, right? Or for some things, does it give a natural language response also? Like tables and bar graph charts are okay. It
Yeah.
shows you the, yeah.
Hmm. Yeah. So if you ask any question, say like what is the, you know, sum total of average order values by enterprise segment, then it will be able to write the code and generate the output apart from generating visualizations as such. So this is a full-fledged sort of a library for addressing not only your queries but also visualization, complex business user questions, etc. Yeah.
Okay. Aditya, I have few questions. So you talked about getting the intent identified. So, and you said that it has a very specific kind of way to do that. But isn't it just a prompt which is being utilized to identify the intent, which we can just copy and use it somewhere else?
Like, let me go back a few slides.
So the first thing you talked about is identification of the intent, right? Now in that, it is utilizing LLM to do that, right? It is not something where it is utilizing some sort of libraries to actually identify. It is an LLM, correct?
So, like, when intent identification, you talk about intent identification in Pandas AI. So
Mhm.
that refers to how your system understands like what you are trying to do with your natural language query before generating the code.
No, that I understand, but
So
that is something
yeah,
which is being done by LLM, or are you saying that it is done by
no.
code?
So in Pandas AI, this is handled through the LLM itself rather than some sort of a separate classifier. So like prompt engineering guides the LLM model to understand the intent and generate
Mhm.
appropriate code in step-by-step sequence.
Okay, okay.
Yeah.
The next question I have is you talked about data residency, but all of this is a free library, right? Or you are you
Yeah,
talking about the PandasAI enterprise service where you're talking about data
no,
residency?
no, no. This is a purely open source library. Just for what you are paying about is uh, like the API calls that are going to happen, and for that only, uh, you are paying. So yeah, there's nothing like Pandas AI Enterprise version or something like that.
Okay,
And
but
yeah.
I have checked on GitHub. They do have an enterprise license, and what they are doing is that there is a specific cold folder called EE which you cannot utilize unless you have enterprise license. So have you looked into that? Because it seems like they are trying to add that enterprise layer into the overall code so that if you have to use for enterprise, you have to take that enterprise code. So that is something we have to look into because we cannot utilize any code in enterprise if such folders are there, which is basically stopping you to utilize that, which is a very common function right now in different open source libraries. So that is something I have checked. So we need to see that if it is actually gonna impose that enterprise specific licensing to us while we are utilizing it as an open source and thinking about utilizing it for any client. So that is something we
So
to look into. Mhm.
Pandas AI as an open source software, like is
If you go to
just a
GitHub,
tool. Yeah, like
yeah.
I still need to check, but as far
Mhm.
as I have seen so far, like it's a tool that you can deploy and operate, and your compliance is probably determined by how you deploy and configure it within your environment. So
No, Pandas, I
yeah,
understand. I'm talking about
yeah.
Pandas AI GitHub code.
Hmm.
You are talking about Pandas
Yeah,
AI, right?
probably I will have to look into that. But for this
Yeah.
50,000 those sort of data set, I was able to, quickly do the prototyping and
Oh
all.
yeah, you can
So
do that. Yeah, yeah.
yeah,
There is no stopping you to actually utilize even for enterprise code. But once they do that, then there can be trademark and other issues. Once they
yeah,
identify
yeah.
that you are utilizing that, it's not like they're gonna
So
stop you right away. So
Mm-hmm.
that is fine.
yeah.
Yeah,
The next
So
question I have is you talked
yeah,
about that PII masking, right? So
yeah.
let's say if I have asked a question that the why is let's say a customer number 200 having some sort of negative balance, right? Now, this is a very specific data about a customer. You talked about that we are sending the schema to the LLM, but if we are not sending that, are we like gonna PII mask? Is like the code masking that number, changing it to something else before sending it to LLM, or is it just gonna send directly to the LLM that query with
So like
schema?
yeah, so like masking logic, we can incorporate some sort of heuristics or hashing for the purpose. So like when you query your data frame, Pandas AI does not send your raw data to the LLM. Instead, it is going to scan the columns for potential names, emails, phone numbers, etc., Aadhaar card IDs, etc., and sort of replace the sensitive values with some generic placeholders like hash, XYZ, something like that. And it is going to send the masked version to the LLM for code generation. And this is thereafter going to execute the generated code on your original unmasked data locally.
Okay. And is this just related to, so this is a default functionality which exists in Pandas AI,
Yeah,
right?
yeah. So like in Pandas AI, you can, import smart data frame, and in you can sort of do enforce privacy. There is a config parameter, and if you need masking regarding some specific columns, you can do that as well. Yeah.
You also talked about that once the code, the Panda code is getting written, that is getting evaluated. So what is utilized to actually evaluate it? Is it an LLM which is evaluating that code, that same LLM?
So, like once you write your, in natural language query, LLM
Mm-hmm.
is going to generate the code, and
Okay.
thereafter happens this code validation, or you see code evaluation thing. So
Mm-hmm.
this is done again by the same LLM itself that is executing that converting that natural language query into the code, because we have specified that LLM API specifically at the first place in the Pandas AI library as to what LLM we are using. So yeah, much for the same sort of thing, same LLM only is going to get utilized.
Okay. And while you are sending the natural language to actually write the code, are you also sending pandas coding, what do you call pandas coding, I would say SOP kind of something to the LLM for it to actually understand what to write? Or does all the LLMs has all the understanding around how to actually write this code?
Yes.
Yeah.
Yeah, can you just repeat? Hello.
Yeah. So my question was that while you are asking pandas, so you are sending a natural language question plus the schema of the data to the LLM, are you also sending some sort of coding related, like what code to write and some sort of references to it so that it understand like what specific code to actually write it into, or the LLMs are by default trained on all the pandas code and they can write anything related to that?
So, like, we are not sending as such any code to the LLM. What we are just sending is your natural language query. For example, like, show me top five customers by revenue. And
Mhm.
the second thing is like schema or metadata of your data frame. Like, what are your column names? What are the column data types? And a few, one or two sample rows for it to infer how does your data look like. So this is what we send to LLM, and in return LLM returns the code, and LLM is just the code writer and not the code executor, and your role is just there to provide the question and the data context which you are sending it by providing the data schema and column names and data types, etc., to the LLM. That's it.
Okay. So, if I think about it, I'm thinking out loud here. Why don't I just use Zebrin to do the same thing like what you have done? So I can actually, if it is just about prompt engineering, I could write a very good prompt or maybe just utilize the prompt for their open source library to actually identify the intent. That's first step. Second step for me to actually fetch the fields from the data, which of course I can fetch in Zebrin flows. Then the third step is for me to actually send the natural language query with the schema to the LLM, which again I can do. And it can write the code. All I need is for the code to actually execute, and I need like a validation. So that is something I need to again check, like pandas, some sort of libraries which can help me with the validation of the code. And that would be it. I could use just an chat, I mean, our chat app, and then it would have the memory also to actually do back and forth around the conversation. I can send all the context around it. I can use any LLM also there. So what is the difference here? Why can't I just use Zbrain flows to do all of this which you are talking about right now? And of course, all the functionalities around enterprise control is inbuilt in Zbrain, as well as like different user controls and access controls is also there. So what's the difference of me to actually utilize Panda AI compared with just Zbrain flows?
Like, as far as my experience with building with ZBrain is concerned, I do not think like ZBrain is able to understand the data frame schemas or data types, or you know, it
No,
is
you are using
merely
LLM to do that, right? You are not using Zebrin to do that. You are using LLM here also, right?
Yeah, but you will have to, provide the data frame awareness to the ZBrain, which I don't think ZBrain as of now has that, because I haven't explored on that dimension. Probably Pandas AI, you can ask like, calculate month over month revenue growth by region and plot it. But in
Hmm.
ZBrain, what you can ask is sort of a lag-based query. Summarize, our Q1 2026 compliance policies and flag any conflicts with the new regulations, something sort of this. So both tools are made for something different purposes, but they can be
Um,
made to work. But
I
yeah,
don't
like
think.
we can use
Yeah.
ZBrain
You need to
retrieval.
explore
Yeah.
more. I don't think that that is not possible to actually utilize that. So anyway, you are saying that they have that knowledge, but that knowledge is something which you are anyway sending to the LLM. So all you need like a knowledge base which which of course Panda AI is actually referring to. That same knowledge base I need to actually create in ZBrain, right? So I don't see like how it is just about RAG. It is more around writing the code, and the code it's not like they have some sort of different way to actually send like the overall code to the LLM, so that the code which is being generated is to the point and it can be utilized by pandas. So if LLM is being used, if that had the memory, of course, I believe that both of it can be done here, right? So it's more around just creating that in here, just replicating the same thing which we have talked about. I don't see a difference here, but maybe someone else can actually add to that. Like, is there something which I am missing? Because for me, this seems like
Yeah,
it can
uh,
all be done in ZBrain. Yeah. Ravi has
probably.
something. Ravi, go ahead.
Yeah.
You are on mute, Ravi.
Yeah.
Yeah.
So Rituraj, regarding your one of actually I wanted to answer one of your question where you asked about whether Pandas AI can be given a kind of SOP or a coding context
Yeah.
that it can explore and use such and such libraries and coding standards. Yes, I think you can give as a context uh, when we are giving an input to Pandas AI. So that can be also done.
Okay. Okay.
Yeah.
But yeah, that same thing we can do in ZBrain also. I mean, I'm
Correct.
still not able to see the difference between like why do we need Pandas AI on top of Pandas, rather
Mm-hmm.
than just using ZBrain, which is inbuilt framework to do all of this. If you are just using LLM, doing simple RAG to fetch the context, which we can build, and if it is deployed, then this is like a separate thing you have to deploy, right, within an enterprise. And then there is enterprise licensing issues also,
Yeah,
which I
that
see right now.
yeah.
So,
So I've
so
answered that. So definitely
Mhm.
it will for adoption, it will kind of requires some kind of legal review, code audits,
Yeah,
and tag gap
correct,
analysis as well before adoption because it carries a uh, repository license and a commit tree is there. Yeah.
correct. Yeah, yeah. Okay.
So I think this session presented by Aditya was quite a good, I would say, something if somebody don't have knowledge on these side of the libraries, they might have gained some knowledge on that. And probably we can come up with something more exciting in the next session or so, like where means we can have a session on what ZBrain can do versus Panda AI, and we can get a means kind of a benefits we can get it from Pandas AI, and probably we can include in ZBrain. What do you say,
Yeah.
Rituraj?
Yeah, that would be great. So that's the idea that if we are
Yeah,
like presenting a new tool, we need to know the differentiation, right? If it is
exactly.
same thing which can be done by the earlier thing which has been adopted by us, so we need to think that if I mean can it be done by the ones which we already have been using, right? So it needs to have some sort of differential, because even if I am going and pitching it to client that can we use Pandas AI, they're gonna ask that why are you
Exactly.
not using ZBrain, right? because we have been
Yeah,
pitching Zbrain that it can do most of the things. You can run Python code into it. You can write code because LLMs are there. So all those things are there. So we need like a very specific USP even if we have to pitch it to the client. So that is something we need to find an answer of.
right. One of the question I do had, but I thought of uh, getting that and answered in next sessions. Probably the question was probably production safe code, how
Yeah.
production safe code it generates pandas AI. So that I think I owe this to Aditya. I think he can explore on that and come up in the next
Yeah.
sessions because that's the most important. Generating a code, it's not a new thing. I think we have several tools available, open source. But generating a production safe code is the what that matters these days.
Yeah.
Yeah, sure. Any
Yep.
more questions? Any?
I think it should be all. We should wrap this session, Aditya. And if somebody have questions on this Pandas AI, do touch base with Aditya because he is doing POCs these days on it and exploring this tool further. Okay.
Sure, I will be shortly sharing all the lecture slides and everything that has been showcased throughout the session. So, if any queries you have, you can feel free to uh, message me or call me up, and I will be good to go. Thank you.
Thank you, Aditya. It was
Thank
exciting.
you.